Hello everyone. In this video, we're going to learn about the sinusoidal function, context, and data modeling. Alright, so let's take a look at the first example. Data modeling from the graphical information. Alright, so let f be a sinusoidal function. The graph of f is given in the xy plane. What is the period of this function? Alright, in order to find the period of the sinusoidal function, we need to find the distance between two maximum or two minimums, right? So we look at the maximum right here, the maximum right here. You don't have exact value, right? Look at the minimum right here. You don't have exact value, right? Because it's right here. So you're gonna pick the midline right here. So the point right here, where's the function start and where's the function end right here, right? So this is complete cycle, right? So the period is the distance from here to here. All right, so it's gonna be 2. So the answer is B. Now let's take a look at example number 2. Let g be a sinusoidal function where g of x equals cosine of 2 times x plus c minus 1. The graph of y equals g of x is given in the xy plane. Which of the following values could represent the constant c? So you know that there are infinitely many values of c. Alright, so the answer choice right here just gives you 4 values. You need to pick the best one, right? Now you know that the cosine function always starts at the maximum values on the y-axis, right? So it starts right here. Alright, now the midline should be the y equal to 0, right? The x-axis. Now in this situation, the midline should be right here. Y equals -1, right? So if you pick these points, the function shift to the left pi over 2. So then c equals pi over 2, right? If you pick this point right here, the function shift to the right pi over 2. So c equals -pi over 2. So based on these graphs, we have two values of c, right? So we look at this one, only this one works. So we pick this one right here, which is the function shift to the left pi over 2, right? Now let's take a look at example number 3, modeling data from the verbal information. Alright, so given the pictures and the word problem right here, now at time t equal 5 seconds, the yo-yo has completed 20 rotation, right? So it tells us that the period is, remember, it's going to be time divided by number of rotation, right? Now the times is going to be 5 seconds divided by 20. So it's going to be 1/4. Alright. Now we use this formula right here to solve for b, right? So b equals 2 pi divided by 1/4, right? So we're going to multiply the top and bottom by 4 to cancel out this one, right? So 4 and 4 cancel out. You have 2 pi times 4, it could be 8 pi over 1, which is 8 pi, right? So b equal 8 pi, right? So only answer this correct, right? Amplitude is absolutely 30 inches long string right here, right? Now let's take a look at example number 4. Alright, so given a word problem with the sinusoidal function h of t equals a times sine b times t plus c plus d, right? In the xy plane, the point h of 0 equals 70, this is the maximum value, and h of 30 equals 52. This is a minimum value, right? We need to find the value of A and D. A stands for amplitude, D stands for the midline, right? So in order to solve for the midline, we use the formula right here, right? In order to solve for amplitudes, we use the formula right here, right? So A equals maximum subtract minimum divided by 2, which is 70 subtract 52 divided by 2, right? So 70 subtract 52 is going to be 18 divided by 2 is going to be 9, right? Now the midline D equals maximum plus minimum divided by 2. So it's going to be 122 divided by 2. It's going to be 61. Now let's take a look at example number 5. Modeling data from analytical information, which is the equation. Alright, so given the sinusoidal function right here, based on the model, which of the following is true? The maximum average monthly temperature is 61.2 degrees. So this is the maximum. We use the formula right here. Alright, given the midline and the amplitudes. So we need to add this guy up, right? So we have 25.7 and 61.2. So it's gonna be 86.9, which is not true, right? So it's wrong. Now, the maximum average monthly temperatures occurs at m equals 1, right? So we substitute 1 for m into this equation to see what happens. So we have T of 1 equals 25.7 sine of pi over 6 times 1 minus 4 plus 61.2, right? So it's going to be 25.7 sine of. Now 1 minus 4 is going to be negative 3. Negative 3 times pi over 6 is going to be negative pi over 2, right? Plus 61.2. Now since this is a sine function, right, the maximum always at pi over 2. Minimums always at 3 pi over 2. Now 3 pi over 2 is the same thing as negative pi over 2. Now if we have the unit circle, we draw the unit circle right here. Alright, so this is the sine axis, right? This is the cosine, right? The maximum right here is 1, right? When x equals pi over 2, right? The minimum is right here, negative 1, when x equals 3 pi over 2 if you go counterclockwise, but x equals negative pi over 2 if you go clockwise, right? So this guy absolutely minimum, not maximum, so this is not the case, right? Now question C, the minimum average monthly temperatures is 35.5. Alright, we use this formula right here, we calculate the minimum. So we have midline should be 61.2 minus 25.7 equals 35.5. So this is the right answer, right? Now question D right here. The minimum average monthly temperatures occurs at m equals 7 months. So we have T of 7 equals 25.7 sine of pi over 6 times 7 minus 4 plus 61.2. Alright, so it's going to be 25.7 sine of 7 minus 4 is going to be 3 times pi over 6 is going to be pi over 2, right? Plus 61.2. Alright, so sine pi over 2 is going to be 1, right? Right here. So it's going to be 25.7 times 1 plus this one, right? So it's going to be 86.9, right? So this is 86.9. Now this one you can calculate 25.7 sine negative pi over 2 is going to be negative sine of pi over 2, right? Because sine function is the odd function right here. So then we're going to apply the formula right here. Alright, so plus 61.2. Now, sine of pi over 2 equals 1. So this guy turns out to be negative 1, right? So negative 25.7 plus 61.2. So it's going to be 35.5. Now, let's take a look at example number 6. Modeling data from numerical information, which is the table. Alright, so the question is, what is the maximum number of nightmare hours predicted by the sinusoidal function model? Alright, so basically we need to write this equation, alright, given the table right here. Alright, so please check out the video in the description below to know how to find the equation using the calculator TI-85 and TI-84 plus CE. Alright, the answer must be C. Now, let's take a look at the last example. The figure shows a pencil sharpener on a level surface. Point B is located at the end of the handle, right here. That is 2 inches from the center of rotation. The handle rotates in a clockwise direction, so which is gonna go this way, and completes 2 rotations every second, right? So from this information we can calculate the period. Remember, the period is gonna be time divided by number of rotation, right? So it's going to be equal to 1 over 2. Alright, so when you have the period, immediately divide the period into 4 quarters, right? So 1/2 divided by 4. So it turns out to be 1 over 8. Alright, so keep that in mind. Each quarter is going to be 1 over 8 seconds, right? Now, at time t equals 0 seconds, point B is located directly below the center of rotation. So here's the center of rotation, and point B right here. The center of rotation is 3 inches above the level of surface, right? So the distance from here to here is gonna be 3, right? Distance from here to here 2. So then we have the distance from here to here is going to be 1, right? Now we need to find the coordinate of 5 points F, G, J, K, and P right here, alright? So let's complete the figure as follows. Alright, so go ahead, draw the midline. Remember that the midline always parallel to the baseline. The baseline is right here. Alright. Now, we need to find the coordinate of point F. So we look at this one right here. Point P right here is at the lowest point. And then after 1.8 seconds, it's go over here, which is the midline, right? And then another 1.8 seconds is go over here, which is the maximum point. So the maximum point should be right here. So we have something on the left right here, which is we don't need to count, right? So obviously the point B, it should be right here. And then the next point right here, which is this point. Alright, so when the handles rotate to the maximum points right here, which is the point F, right? Now, we know that the distance from the center to the baseline right here is 3, right? Distance from here to here 2, and distance from the handle to the baseline is 1, right? Because 3 minus 2 equals 1, right? Now we know that the midline has the value from the center to the baseline, which is 3, right? When the handle go to the maximum, which is the distance from here to here, 2, right? 2 plus 3, which is 5, right? And then the lowest point right here, which is the distance from here to here, which is 1, right? Now, at the point F, which is the point right here, the highest point right here, the lowest point right here at t equal to 0, right? Now, every single quarter, we just keep adding 1/8. So this guy should be 1/8. This guy should be 2/8. 2/8, which means 1/4, right? So we have 1/4 right here. Alright, because this is the highest point, which is the height should be 5, right? So we have 5 right here. Now, when the handle go to this point, this is the midline, right? So we have 2/8. You're gonna add 1/8. It should be 3/8. So point G right here should be 3/8. Now the height should be 3, right? Alright, so if the handle goes over here and this is the lowest point, which means the height is 1, right? Now time right here is 3/8, right? Now right here you keep adding 1/8, so it could be 4/8, so it could be 1/2, right? So this guy should be 1/2. Now when it go back over the midline right here, alright, so you keep adding 1/8. So since I have 4/8 right here, I just use 4/8, right? I'm not gonna use 1/2, right? Because 4/8 is actually 1/2. Now I keep adding 1/8, so it could be 5/8, right? So right here should be 5/8, the midline, right? Now the height should be 3. Now when it go back to the highest point right here, which is point P right here, so I have 5/8, I keep adding 1/8, so it could be 6/8. I simplify, it could be 3/4, right? So I have 3/4 right here, and then the height should be 5, right? Now let's move on to question B. The function h can be written in the form of h of t equal a sine b times t plus c plus d. Find the values of constant a, b, c, and d. Alright, so first we need to find the amplitude. Now we know that amplitude equals maximum subtract minimum divided by 2, right? So it could be 5 subtract 1 divided by 2. It's gonna be 2, right? Now, in order to solve for b, we need to find the period, right? So the period is 1/2 right here, right? So we have the period equals 2 pi over b. So then b equals 2 pi divided by period, which means 1/2, right? So I multiply the top and bottom by 2, right? So 2 pi times 2 equals 4 pi. The bottom right here cancel out. I have 1, which is 4 pi, right? So b equals 4 pi. Alright, now next one, I need to solve for d, right? D is the midline, right? So d equals 3 right here. Now, last, I need to solve for c. Alright, so I know that the sine function always starts at the origin, right? Which is the midline, right? So you can pick c right here, which means it shifts to the right 5/8 right here. Alright, so c equals negative 5/8. Now, let's move on to question C. Refer to the graph of h in part A. The t coordinate of the point J and point K are T1 and T2. So point J and K should be this guy right here. Alright, on the interval T1, T2, which of the following is true about the function h? Alright, since The y values right here is positive, right? So the function is positive, right? So we need to eliminate C and D. Now we draw the tangent line right here. Alright, and we see that the rate of change is positive. Use the Christmas tree trick, right? If the lines go in this way, the rate of change is positive. If the lines go in this way, the rate of change is negative. So the rate of change is positive, which means the function is increasing. Right? So the answer must be A. Right? Now, C2. Describe how the rate of change of the function h is changing over the interval t1, t2. Alright, so the rate of change is increasing because the function is concave up, and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.